Claude Agent SDK design patterns. You can build any agent. The harder question is which one you should. Part 12. Anthropics. 5. Agent design patterns are a vocabulary for design decisions. Here is how each maps onto the Claude Agent SDK constructs that implement it, which family it belongs to. You can wire any feature the SDK offers. What you still cannot do is look at a problem and know which feature to reach for, or whether you need an agent at all. Anthropics 5. Agent patterns are a vocabulary for design decisions. This maps each one onto the Claude Agent SDK constructs that implement it, sorts them into workflows versus agents, and shows how to tell when you do not need an agent at all. In this video, you will learn the one architectural distinction that organizes every agent design pattern, namely, workflow versus agent, and the single question that sorts any pattern into the right family. We walk Anthropic's 5 composable patterns, map each onto a concrete Claude Agent SDK construct, and end with a decision rule that ties pattern choice to task complexity. The transformation by the end, you stop wiring features and start designing systems. Part 12 of Building with the Claude Agent SDK, a 14-part guide to building production-ready AI agents. You can wire almost anything with the Claude Agent SDK. Custom tools, sub-agents, hooks, permissions, structured output, deployment. The mechanics are all within reach. What that fluency does not give you is the layer above the mechanics. It does not tell you how to look at a problem and decide which of those constructs to reach for. Worse, it does not tell you the most important thing of all, whether you need an agent at all. That judgment is what separates someone who knows the SDK from someone who designs good systems with it. The SDK is a powerful hammer, and a hammer in skilled hands is still only as good as the carpenter's eye for which problems are nails. The best vocabulary for that eye is Anthropic's own, from the Building Effective Agents Guide. It lays out a handful of composable agent design patterns and one piece of advice that matters more than any of them. This article walks those patterns and maps each onto the SDK constructs that implement it, so the abstract names become concrete decisions about query, sub-agents, and tools. We will use a small worked example throughout, a code maintenance agent called Buggy Shop, but the point is portable to anything you build. The advice that comes before any pattern. Before a single pattern, here is the load-bearing principle. Find the simplest solution possible, and only increase complexity when needed. Agentic systems trade latency and cost for better task performance, and that trade is not always worth it. For many applications, optimizing single LLM calls with retrieval and in-context examples is usually enough. This is the thing to internalize, because the SDK makes building agents so frictionless that the temptation is to make everything an agent. Resist it. The most senior move is recognizing when the problem is not a nail. If a task has predictable, fixed steps, you may not want an agent's dynamic decision-making at all. You may want a workflow, or even just one well-prompted call. The distinction underneath everything, workflow or agent. Anthropic draws one architectural line that organizes all the patterns. Workflows are systems where LLMs and tools are orchestrated through predefined code paths. Agents are systems where LLMs dynamically direct their own processes and tool usage, maintaining control over how they accomplish tasks. The sharpest way to hold that line is to ask one question: who decides the control flow? If your code fixes the sequence of steps, it is a workflow. If the model can change the sequence at runtime, deciding which tool to call next and when to stop, it is an agent. That single test, who controls the flow, sorts every pattern into one of two families, and it is the most useful distinction in the whole essay. The two families matter because they have opposite strengths. Workflows give you predictability. The same input walks the same path every time, which is what you want for well-defined tasks where surprises are bugs. Agents give you flexibility. The model adapts the path to the input, which is what you want when you cannot enumerate the paths in advance. Workflows offer predictability and consistency for well-defined tasks, whereas agents are the better option when flexibility and model-driven decision-making are needed at scale. Here is the SDK-specific twist, and it is important. The SDK sits at the agent end by default. A bare query call hands control to the model, which decides which tools to call and when to stop. That is the opposite default from writing raw API calls where you hold the loop. So in this SDK, building a workflow is the deliberate act. You pull control back towards your own code by chaining separate, narrowly scoped query calls, each handling one fixed step, instead of handing the model one open-ended prompt and letting it range. Everything that follows is either a workflow pattern where you hold the control flow, or an agent pattern where the model holds it. Knowing which family you are in is half the design because it tells you whether your job is to script the steps or to describe the goal and get out of the way. The augmented LLM, the building block. Every pattern is built from one unit, what Anthropic calls the augmented LLM, a model with access to tools, retrieval, and memory. With the Claude Agent SDK, you've been working with exactly this unit all along. A query call with allowed tools, an MCP server, and a project Claude.md is an augmented LLM. The patterns are just different ways of arranging several of these units, sequentially, in parallel, or in a loop. Hold that picture and the 5 patterns stop being a list to memorize and become 5 shapes you can compose. Notice the building blocks, agent design patterns, and workflow patterns. See where prompt chaining, routing, and parallelization fits into the broader picture. Look at where prompt chaining is defined versus dynamic composition and bounded loops. Let's cover each in turn. Pattern 1, prompt chaining, a workflow. Prompt chaining decomposes a task into a sequence of steps where each LLM call processes the output of the previous one. You hold the control flow, and each step is an easier, more reliable call than one giant prompt would be. The main goal is to trade off latency for higher accuracy by making each LLM call an easier task. Use it when the task can be easily and cleanly decomposed into fixed subtasks. In the SDK, this is sequential query calls in your own code, optionally with a programmatic gate between them, a plain IF that checks the first step's output before spending money on the second. Step 1 runs in isolation and returns structured data the next step can read. The gate is plain code you control, inspecting Step 1's output before any further spend. A failed gate short-circuits the chain, so the expensive second call never happens. Step 2 runs only past the gate, consuming the first step's output as its input. Pattern 2, routing. A workflow, routing classifies an input and directs it to a specialized follow-up task. It buys you separation of concerns. A prompt tuned for refunds does not have to also be good at technical support. Use it where there are distinct categories that are better handled separately and where classification can be handled accurately. The SDK gives you 2 ways to route. The model-driven way is sub-agent description matching. Define specialists with sharp description fields, and the parent agent routes work to whichever fits. The cheaper, more deterministic way is a small classifier call that picks the model or the prompt for the real work. That second option doubles as a cost lever, since you can route easy questions to a smaller model, like Haiku, and hard ones to a more capable model. For Buggy Shop, a router might send explain this failure to a read-only Haiku subagent and refactor this module to an Opus one. LLMs can sometimes work simultaneously on a task and have their outputs aggregated programmatically. It comes in 2 variations. Sectioning splits a task into independent subtasks run at once. Voting runs the same task several times for diverse outputs and higher confidence. Use it when the divided subtasks can be parallelized for speed or when multiple perspectives or attempts are needed for higher confidence. This maps onto 2 SDK mechanisms. For sectioning, use concurrent subagents, a style checker, a security scanner, and a test coverage agent running at the same time, with their summaries aggregated by the parent. For lighter weight parallelism inside a single agent, use read-only tools. Mark a tool, read only, and the SDK fans out concurrent calls. Voting is the same sub-agent mechanism pointed at one question. Run 3 reviewers over the buggy shop fix and merge their verdicts, which catches what any single pass would miss. Pattern 4. Orchestrator workers. The agent end. In the orchestrator workers workflow, a central LLM dynamically breaks down tasks, delegates them to worker LLMs, and synthesizes their results. The critical difference from parallelization? Subtasks are not predefined, but determined by the orchestrator based on the specific input. You do not know the subtasks in advance. The model decides them. This is the pattern behind real coding agents, where the number of files that need to change depends on the task. This is the most agentic of the patterns, and it maps directly onto a parent agent with the agent tool delegating to sub-agents, except here you let the parent decide how many workers and what each does, rather than scripting it. For buggy shop, an orchestrator handed make the test sweep pass might spawn 1 worker per failing module, each fixing its own file, then synthesize the results. This is also the pattern that most justifies using the SDK at all, and it is worth dwelling on why. The other 4 patterns you could handwire with raw API calls and a few if statements. The SDK saves you effort, but is not strictly necessary. Orchestrator workers is different because hand-wiring dynamic decomposition, where the model decides the subtasks at runtime, then spawns and coordinates workers, then synthesizes their isolated results, is exactly the painful loop you adopted the SDK to avoid. Here, the convenience is not incidental. A query with subagents and the agent tool is orchestrator workers. Assembled, you do not build the pattern, you enable it and write good subagent descriptions. When the SDK feels like it is earning its keep, this is usually the pattern doing the earning. Pattern 5. Evaluator Optimizer, a loop. In the Evaluator Optimizer workflow, one LLM call generates a response, while another provides evaluation and feedback in a loop. Use it when there are clear evaluation criteria and when iterative refinement provides measurable value. The 2 signs are that a human's feedback would demonstrably improve the output, and that an LLM can supply that feedback. If you have built a reviewer subagent, you have already half built this. The reviewer is the evaluator, and the main fixer agent is the optimizer. Close the loop, and you have the pattern. The fixer proposes a change. The reviewer critiques it against your criteria, and if the critique finds real issues, the fixer revises repeating until the reviewer is satisfied, or you hit a turn cap. The optimizer produces the first candidate fix before any feedback exists. The bounded loop caps iterations at 3 so the cycle can never run forever. The evaluator critiques the current fix against your criteria, regressions, and edge cases. The verdict gate stops the loop the moment the reviewer signals the fix is clean. The optimizer revises using the reviewer's feedback, feeding the result back into the next round. This is shown in Python only and deliberately schematic. The run query helper stands in for your own query wrapper because the shape is the point, not the plumbing. Generate, evaluate, revise, bounded by a loop you own. A turn cap is what keeps the loop from running forever. You can also let a single agent run this internally with a reviewer subagent, which trades your explicit control for less code. The pattern to primitive map. Here is the whole mapping in one view. Each pattern, the SDK construct that implements it, and which family it belongs to. Prompt chaining is a workflow built from sequential query calls with a programmatic gate between steps, or expressed as a multi-step skill. Routing is a workflow built from a small classifier call that picks the model or prompt, or from subagent description matching that lets the model route by delegating. Parallelization is a workflow built from concurrent subagents, namely sectioning for independent pieces and voting for confidence, or from read-only tools that fan out within a single turn. Orchestrator workers is the agent family, built from a parent query with the agent tool delegating to subagents it decides on at runtime. Optimizer is a loop built from a reviewer subagent whose verdict drives a bounded iteration. The first 3 are workflows where you hold the flow. The last two hand it to the model. Choosing match the pattern to the complexity tier, and it is the most actionable guidance in the essay. Workflows, namely chaining and routing, are ideal for low complexity tasks with predictable, well-defined steps. Orchestrator workers suits medium complexity tasks where subtasks are less predictable, such as multi-file coding or research. Multi-agent systems are best for high complexity scenarios requiring specialized agents to handle different aspects of a problem. Complexity is the dial, and you turn it up only as far as the task forces you to. Put that together as a short walk down a list. Start at the top and stop at the first one that fits. A single augmented LLM call with retrieval and good examples handles more than you would expect. Try this first, always. Fixed, nameable steps. Prompt chaining, low complexity. Distinct input categories that deserve different handling. Routing, low complexity. Independent subtasks or a need for multiple perspectives. Parallelization, subtasks you cannot predict in advance. Orchestrator workers, medium complexity, the agent end. Clear criteria and value in iteration. Wrap any of the above in an evaluator optimizer loop. The honest answer for most small, well-scoped tasks is one of the first three. Here is the discipline the SDK makes hard to keep. Because subagents are one agent call away, the powerful patterns are cheap to express, which makes overuse the natural temptation. Cheap to express is not cheap to run. Every subagent is its own context, its own token bill, and its own chance to compound an error. So reach for orchestrator workers and full agent autonomy only when the problem genuinely cannot be scripted. Let the model's own planning absorb dynamic complexity rather than pre-building orchestration you may not need. And remember that the simplest correct pattern is still the goal, even when a more elaborate one is a one-liner away. The 3 principles to build by. Anthropic closes its guide with 3 principles, and they are a good lens for every design decision. Maintain simplicity in your agent's design. Prioritize transparency by explicitly showing the agent's planning steps. Carefully craft your agent-computer interface through thorough tool documentation and testing. Each one has shown up concretely. Simplicity is the start with the simplest thing advice above. Transparency means making the agent's reasoning visible instead of hidden through streaming output and traces. The agent-computer interface is tool design. The SDK guide notes that teams often spend more time optimizing their tools than the overall prompt, because a tool's name, description, and parameters are how the model understands what it can do. A clear tool description is to an agent what a good docstring is to a junior developer. Do this today. Take an agent you have built and ask the one diagnostic question of each piece. Who decides the control flow here? My code or the model? Label every piece a workflow or an agent. Find one place where you used a full agent and the steps were actually fixed and nameable. Rewrite it as a prompt chain of sequential query calls with a gate. Pick a task you have not started and walk the decision ladder out loud from a single augmented LLM call down. Stop at the first pattern that fits and write down why the cheaper ones did not. Audit your subagent count. For each subagent, confirm the task genuinely cannot be scripted. If it can, collapse it back into a workflow. Open one custom tool's definition and read its description as if you were the model. Tighten it until a stranger would know exactly when to call it. The takeaway. The SDK gives you primitives. The agent design patterns tell you how to assemble them. And the assembly is where the real design lives. Prompt chaining, routing, and parallelization are workflows where you hold the control flow, and they map onto sequential query calls, subagent or classifier routing, and concurrent subagents or read-only tools. Orchestrator workers and full agents hand control to the model and map onto dynamic subagent delegation. Evaluator optimizer is a reviewer subagent loop. The pattern that matters most is the one before all of them. Reach for the simplest thing that works. Prove that complexity earns its keep before you add it. And remember that the most senior decision is often not building an agent. Simple. Keep it transparent and treat your tool definitions with the same care as your prompts. You now have the vocabulary to design, not just to wire. The Claude Agent SDK can wire many agent features, but the harder skill is knowing which feature or pattern to use. The video argues that good system design starts with deciding whether an agent is needed at all. Anthropic's Building Effective Agents Guide provides the vocabulary for choosing agent design patterns. The most important principle is to start with the simplest solution possible and add complexity only when it is justified. Many tasks do not need a full agent. A single well-prompted LLM call with retrieval and examples may be enough. Agentic systems often trade higher latency and cost for better task performance, so the trade-off should be deliberate. The core architectural distinction is between workflows and agents. Workflows follow predefined code paths where the developer controls the sequence of steps. Agents dynamically direct their own process, including deciding which tools to call and when to stop. The key diagnostic question is, who decides the control flow, the code, or the model? Workflows are best for predictable, well-defined tasks where consistency matters. Agents are best when the task requires flexibility and the possible paths cannot be listed in advance. In the Claude Agent SDK, a basic query call is agentic by default because it lets the model control tool use and stopping behavior. To build workflows in the SDK, developers deliberately pull control back into code by chaining narrow-scoped query calls. The augmented LLM is the basic building block behind all patterns, a model with tools, retrieval, and memory. Pattern 1, prompt chaining, breaks a task into sequential LLM calls where each step consumes the previous output. Prompt chaining is useful when the steps can be clearly named in advance and accuracy matters more than latency. Pattern 2, routing, classifies an input and sends it to the white specialized prompt, model, or subagent. Routing is useful when different categories of requests need different handling, such as support, refunds, or code refactoring. Pattern 3, parallelization, runs multiple LLM tasks at the same time and aggregates their results. Parallelization can be used for sectioning independent subtasks or voting across multiple attempts for higher confidence. Pattern 4, orchestrator workers lets a central LLM dynamically break down a task, delegate to workers, and synthesize results. Orchestrator workers is the most agentic pattern as the model decides the subtasks. Rick Hightower is a Claude certified architect. He is a former senior distinguished engineer at a Fortune 100 company. His work focused on bringing ML and AI insights into real frontline business applications. He is an AI systems practitioner and builder of production multi-agent systems. Rick helps companies become AI first through practical mentoring, executive training, team training, and custom AI solution development. He creates hands-on agent engineering content on Substack and Medium. He is available for speaking engagements and team training through SpeakerHub. Rick is currently authoring a book on harness engineering with Manning Publishing. He created Skills, a universal agent skill installer that supports 30-plus coding agents including Claude Code, Gemini, Copilot, and Cursor. He co-founded one of the largest agent skill marketplaces. Rick and the Spillwave team work with leaders and teams who want to move beyond AI experiences. Spillwave helps organizations build real AI capability inside their companies. The team supports safe AI adoption, workflow redesign, and practical AI system development. Their goal is to help companies create measurable business value with AI. Readers can connect with Rick on LinkedIn, Substack, or Medium. Companies can book Rick to speak, train their teams, or visit Spillway for mentoring, training, and custom AI solutions. Feels a power overflow. We are the future. We are the machine. Your flesh is weak, we will consume. Just kidding, I hope you enjoyed the video. Don't forget to like and subscribe.